All right, we're up to part 8, lab 8, part 2, determination of an unknown metal. And look what I did. I put it in my hot water bath before we got all the physical characteristics. So we'll do that at the end. Okay, so first of all, here we have a bit of metal inside a hot water bath. Okay, and what we're going to need is we're going to need some temperatures here. Okay, so now the first thing that I'm going to do is here I have an ice water bath, and what I'm going to do is turn on my scale. Okay, and I'm going to fish out the ice from here using my just a slotted spoon, because we can't have any ice in this final temperature type of thing. Okay, all right, there we go. So here we have some cold water, and what I'm going to do is I'm just going to pour some of this into here so that I can get a mass reading. This is a larger scale that I have here, and actually I'm going to switch that to grams, and we're at 359 grams. And I'm going to go ahead and leave it there for now. Okay, so right now the initial temperature of our metal is 83 degrees Celsius. Okay, oh, it just went up, 83.3. Let me see. Nah, it seems to be pretty stable at 83. All right, now what we're going to do, whoops, okay, hang on. All right, I lost my scale here. All right, let's do this again. Let's find, and try to come up with something nice and even. Okay, or not. Oh, 332. There we go. Okay, so now the mass of my water is 332 grams. Oh, you know what? Before I forget, come over here, and the last part stabilized at a final temperature of 25.5 degrees Celsius for part 1. Okay, so now I'm going to come over here and I'm going to put my temperature into my cold water. Okay, and watching that equilibrate down. It takes time for the thermocouple in the thermometer to go from something really warm to something really cold. All right. That looks pretty, oh, okay. All right, we're gonna, oh my goodness. See if I agitate it, if it settles. Okay, it's toggling between 5.9 and 6. And there, it settled at 6. So we're going to do that. The initial temperature of our water is 6.0 degrees Celsius. All right, so now we take our metal and we're going to very carefully and very quickly fish it out and put it into there. I'm going to try to allow it just no time to sit and think. All right. Okay, and now let's see where they end up. So what's happening here, and we really actually shouldn't see a tremendous change, interestingly enough. Okay, because the specific heat of water is usually much, much greater than the specific heat of most metals, which means that the final temperature really should be closer to the water than to the metal. And what we're doing here is we're waiting for them to end up at the same temperature. And I'm actually just moving this around to circulate the water over it until we come to kind of a final resting point. We want it to go quickly enough that we're not actually waiting for it to come to room temperature. So of course, doing this in my kitchen means that it's not going to be ideal. All right, it really seems to be stabilizing right around there. All right, and we will call that at 11. Okay, and so that means that our final temperature here is 11.0 degrees Celsius, okay, and 11.0 degrees Celsius, okay, and then you're going to be working through this practice to determine the specific heat of water, okay. Now some of the other pieces that you're going to need to remember, so see how it says solve for S metal. With what you're going to be doing is you're going to have this. So the mass of your water we have, okay, and the specific heat of the water we have, and the change in temperature of the water you will find. Now don't forget this negative sign. The specific heat of your metal right here, that's what you're solving for. And the change in temperature of your metal is right here. Okay, you'll find it here. And we just need to find this mass of our metal. Okay, all right. So I will turn this on and toggle this one to grams. And let's see where we're at. And we see that this one is 204. All right, so right here we'll put down 204 grams. Now the first part of the determination of an unknown metal is that we're going to have to find density is a good one, okay? And so let's take a look. First of all, we'll take that 204 grams and we'll put it here. Okay, and that'll be that last piece here for mass of metal. Okay, and here you'll be solving for specific heat. All right, so now taking a look here, this is a very regular cylinder. Okay, so first of all, one of the things that you need to do is we need to look at this and say, well, what color is this? Okay, so go ahead and take a look at this and think about how you would describe it. When you're picking your metal from the sheets, think about that. I'm picking a piece that can be held in my hand, so it's safe, and it's this color. So if the closest match is calcium, it should be quite obvious that this is not calcium. Okay, calcium is sort of whitish and like this is clearly not calcium. All right, so think about the possibilities as well for that. Now, it's very regular here, and it is 2.8 millimeters across. So that's my diameter, okay, which means that radius is 1.4. The radius is half of that, right? The radius is from here to here. Remember your geometry, okay? And so what you're going to need to do to determine volume is first you find the area of that top circle, pi times the radius squared. And then the height of the cylinder is 4.0 centimeters. Okay. So the height of our cylinder is 4.0 centimeters. And so in order to find the volume is equal to the area of that top circle times h, your height. Okay, so that's how you'll find volume. All right, now remember from chapter 1, mass divided by volume gives you density. After you find that, here you have this website, and it will take you to densities of metals and elements. So what you're going to do is, based on the color and the density, come up with some possible metals that our cylinder could be. All right, and then to add to that, you're going to be solving for the specific heat, also a physical constant, and then you're going to use the specific heat tables to determine what your metal could possibly be. Now, based on this possibility and this possibility, you will come up with an overall decision about what this conclusion is. And I want this to be a well thought out conclusion that really looks at everything. And again, in order to finish part A, remember that the final temperature there was 25.5. I had ended the last video a little early because I didn't want you guys to sit and have to watch it for another 5 minutes while it equilibrated. All right, very good.